Alright, so where we left off at the end of the last video is we were placing our multiple physical volumes using the one logical volume, and we were making a 3x3 array of pixels, and we started displacing the X, and as we saw, we had a bit of a shift in our placement. So instead of being nicely centered place, we've got a bit of a shift to the left. So remember, we were placing it this dx pose, and what we did is we calculated the range that these detectors or pixels were being placed over. So we had our range defined as 3 by the pixel spacing, so this would be 30. So, but our problem is that since if we've only got 2 detectors, then we've got a total range of 1. Then, as in we've only got a distance of 10. We haven't got a distance of 20. So I just forgot to leave a -1 off. So I should have number dx -1. Let's put that for the y. So if I compile that now, hopefully it's a bit more symmetrical looking. So let's just compile that again and quickly visualize it. And let's rotate it. So yep, that looks much more centered. So it's a bit of an improvement. So before, when we were placing all these previous volumes, we had this copy ID here, and we just had it at 0 since we were just placing single volumes. But since we now placing a single logical volume multiple times, we now want to specify the physical volume when we actually place it. So let's create a variable just called pixel copy number and initialize that to 0. And we'll place this pixel number here, and every time this physical volume gets placed, we'll increase this count by 1. So I'm doing it this way instead of just using the dx here, just because we're going to add another for loop in the y. So this is just easier since it's just going to track every time we place a volume, we'll increase the count. So, and while I'm making changes, I'm actually just gonna spit out the X position, sorry, G out, and we'll actually also have a copy number here. So we'll go copy number there, and then we're gonna place the X. So we'll go to X equals, and we'll output it as centimeters. So let's just quickly compile that again. So now when we run it, then if we look at the output, then you can see we've got our checking for overlaps here as always, but we've got our copy ID 0 and our x equals -10, copy ID 1 x equals 0, and centimeters, remember, and then for our copy ID of 2, then our x is equal to 10. So far so good. So let's now add the y pixels, or the spacing the y. So since we've done our x and this is all symmetrical, we've done most of the hard work already, so we can just copy our existing code and just change up the variables a bit. So let's just change this to let's showcase good programming technique and not have hard-coded numbers. So I'm just going to replace that from 3 to a number of dy in case we wanted to change it to 5 or something. So let's now add our dy position and just change all these to y's, and hopefully it magically works. Well, not magically, but hopefully it works as expected. So it looks good, and let's now add our y position here. So I didn't call this y. Good. And dy pos. Let's force it to be centimeters. And now we'll add our y spacing here in our position vector. And so much easier once we've already got the x spacing set up. So let's just compile that again. And what did I do here? Range dy, that's meant to be small, is it? 137, dy pos. Did I not define it? Right. I was going to do a start position at one point, but just put in the for loop. Dy, well, just put caps lock on, dy. So let's do that once again. Whoops, dmake. So let's give that visualization. Looking good. We're already seeing the y's. So we rotate it now. We see our 3x3 array. It looks nice and centered. And if we go up in the output of our copy numbers, we can go through them all. So copy number 0, -10, -10. So it starts here, the for loop. And then the next one is y equals 0. So we're going through the y's second because we had our x and our y. So dx and then dy. So we go through the dy's first. So start here, go up here. Then the next dx should be 0. So center one, go up and up, so on and so on. And none of the volumes overlap, so that's good. But often if you're doing a detector which has much more like realistic or complicated placing, it's quite common to have some sort of offset, and you'll get some overlaps quite often. So always be aware with overlaps, especially with detectors, since it's very important that you're not getting overlaps. So let's say we had our placement too close together. In fact, let's just do it now. So let's say I had my placement set to 7 in the x, and I'm thinking, 5 and 7, 7's bigger than 5, I'm going to be okay. But when I actually run it and it checks for the volume placement, well, that's good. Because I'm timesing my total. Whoops, silly me. So let's change it to a 4 for the pixel spacing. So remember, this was from the center to the center. And so if we just compile again, so now we'll get a ugly picture. So now when we do the reveal, we get this 3 volumes. So when we actually go up here, we see we've got all these overlaps. So always important to check for overlaps and visualize when you're doing spacings. especially when they're irregular spacings. So let's just change that to 10. And also, while we're talking about generating space volumes, always try to avoid anything hard-coded, so avoid having like hard-coded to 3 and 3. Always try to use variables, so if the design ever changes or you need to investigate some other design or effect, always good to just be able to change a single number and have it all changed. Actually, that will produce an overlap, I think. 5, 50. Oh, that'd be okay, I think. So let's just change it 5, get some fun colors, see if it's fully contained in our mother volume of the 50 centimeter cube. Yeah, looks good. Still in there. So 245, 245. Good placing. So that covers like basics of how to do like pixelated or replicated placements. Well, I should be careful when I say replicated, because replicated volumes are a specific thing in Geant4, which I might cover in a separate video. But whenever you're doing placements of volumes, just make sure you've got your copy number being increased or incremented each time you're placing the physical volume, and make sure you check for your overlaps and or your spacing is set up correctly. And as you saw me fall to, make sure your symmetry is all set up, because as you saw with me, I had it shifted by a bit due to this -1. So in the next video, I'll just show a bit of a brief how we can retrieve this information on the level of the step / the track, and just give you a quick idea how we can store quantities from these replicated volumes.